No. Gohil. Okay, there. Okay. Good afternoon, everyone. Good afternoon, everyone. And thanks to SECA and other institutes for inviting me as a moderator for this panel discussion. Now I would like to invite Mr. Jitendra Trivedi, Member Governing Council, Composite Association, as a panelist for this. Welcome, sir. Other panel member is Mr. Sri Naimesh Patel. He is the head Optical Payload Mechanical Division, ISRO, Ahmedabad. Welcome, sir. Another panelist, Mr. Lalit Khatri, who is Director, Link Composites. Welcome. We have with us Dr. Hemant Chouhan from the Ahmedabad University as another panelist. We are given maximum 45 minutes time, so we'll try to finish in 30 to 40 minutes so that later on we have 5 minutes remaining. The topic of the panel discussion is present challenges and future ahead of lightweight composite industries in India. So since morning we have various lectures and insightful information regarding the composites. So as we have experts in this field and will be whatever the knowledge we have gained, based on that we'll be having this discussion on this. So it will be result into some fruitful outcome for this panel discussion. So, sir, what we have planned is I'll be floating the question and we'll be having the discussion. And first, you will give your views on that, and then later on, if anybody wants to ask or some counter questions are there, that will be there. Is it okay, sir? Okay. So first, I'll be asking questions to Mr. Jitendra Mistry, who is Governing Council, Composite Association. The first question is, in light of the current challenges faced by lightweight composite industry in India, particularly the high production cost and the lack of, what steps is Council taking to address these issues? Yes. You can sir speak from.
Audible. Well, I think audible. I'm audible. Yes. When we talk about lightweight composites, so I need to also give you a little bit of background on what 360-degree changes that has happened. So while coming today to the morning, I saw in your morning panel, led by from ISRO, also Chouhan from Reliance. One thing that came to my mind was when industry started. I'm not talking about 60 years back, but I'm talking about last 30 years, 35, 30. At that time, those who were manufacturers have become end user, and those who were end user have become manufacturers. So this is the 360-degree. So giving you two classic examples of how this transition has happened in composites. I'm talking about way back in 1984-85 in transport industry, mainly in railways. Eastern Railway was the first one who started SMC unit in Calcutta, manufacturing units. So they were manufacturer for composites. Today, with Vande Bharat Express, they are the largest end user of composites. So this is one example. What Reliance started in petrochemicals, equipment for chemical and piping system, today they are manufacturers. So this is the transition, change that has happened, and it is happening in most of the application areas. This is one part of it. The second part of it, what Mr. Gohil has asked me about what association or what industry per se can do. So there are challenges there. So there are challenges in terms of, in the morning it was talked about what is the way to collaborate. And the collaboration and the knowledge share has to be on the basis of commercial viability of any of these associations. Merely research and development, merely saying that this product is good, this product will work well, is not going to help. So that challenge somehow the industry has to overcome, somehow the knowledge partners, knowledge centers need to understand what is the need of the industry and how those needs can be fulfilled in most competitive way. This is the two things that I see as what we need to look at in the period from now onwards for next 10 or 15 years.
Sir has described that the challenges and need of the industry, that is the main focus. Are there any specific initiatives or collaborations in place to lower production cost and enhance the skill development within the industry? It's open for all.
So, I would just like to, Trivedi sir told that this is the need for the industry, technology and the training. So we are also taking initiative there. Very soon, going to start a technology training center in Vadodara. It is already under development. It will take 1 year time. There we are focusing to provide technology, information, training to new technocrats who can learn their technology and then serve to industry. It's a kind of understanding, and they can come with their idea or their challenges. We have a team of specialists, experts, they can provide the solution. Further, we are also going to develop a tooling and mold making center there. So, in the composite, the tooling and mold making is the main challenge. Because if your mold is good, you have the technology, but the mold is not as safe, so you cannot make the part. We are going to offer a technology for mold making, and somebody wants to take a trial or they want to make a mold in our facility, we are also offering that we are going to offer to industry.
Thank you. I think R.K. Singh sir has already taken this initiative, and this is the result for that. It is step in this direction. So this is one of the things. Now my next question is to Mr. Naimesh Patel, specific related to ISRO. Given the critical role of lightweight in the design and performance of optical payload for space missions, how is ISRO addressing challenges of high production cost and limited domestic supply of advanced composites materials?
Well, actually, morning our directors said that we would like to see the number plates from the space. So that demands like very large optical instruments, optical telescopes. Now, if we are going for a very large telescope, and if you think of use of metal usage will be a very heavy. It will be like of the order of 100 kg payloads. Now, launching 1 kg mass into a orbit around 10 lakhs rupees. So, if we shift from metal to composite, we can reduce weight by half or even lesser than that. So that way we can reduce the cost with the use of composite. Now within the composite, how we can further reduce the cost? One is right now whatever design right now ISRO or SAC is doing a design of composite, and we are procuring material from outside the countries because of speciality or because of requirement of like high modulus, high stiffness, high strength. So if Indian industry can make those fibers, if they make resins within India, we can reduce the cost of import, or we can reduce the cost of final product. Apart from that, there are two categories. One is lightweight, only a lightweighting. We need to reduce. Other requirement in case of especially for optical payloads, we need a very high stiffness. Reason is like when we are on the ground, there is a gravity. The gravity is acting on the hardware. So even though we use a lighter material, it will be under gravity. Once we go to a space, there is absence of gravity, and because of that, the absence of gravity force, structural shape gets changed, and that affects the optical performance or performance of the payload. So with the use of high stiffness, we can eliminate that issue. So if we right now we are procuring those high stiffness fibers from outside, if we can make in India, it will have a cost benefit. Second aspect is like we need a low thermal expansion, because in orbit we have a lot of temperature variation. So in the temperature variation, if we have a fiber, if India can make a fiber with a low thermal expansion, that will make our instrument less sensitive to temperature. And in addition to that, if we add some thermal conductivity into a fiber, that will reduce the temperature gradient. So right now, this technology or the fibers, whatever we are getting, it's from outside. If some industry in the India, if they can fabricate, so that will have a cost benefit. If I recall that when I joined in 20 years back, we were not thinking of even developing composite within the India. We used to procure it from STM outside. Those camera structure we used to get it from outside, which was costing almost, even today also, whatever cost they costed at 20 years back, we are able to manufacture in half or one third of cost at present. So that time we procure full hardware from outside. Now at present dates we are designing, we are procuring fiber only from outside. By that we are reducing price by half or one third. If you are fabricating fibers and resin within the India, that will further reduce the cost composite, especially for optical fibers and remote.
Are there any partnerships or in-house developments which are aimed at overcoming these challenges to ensure reliability and efficiency of the future?
Right now, I mean, within our SAC, few of my friends are here who are dealing in the design and development of composites. So right now, our objective is not to develop fiber or resin. We would like to use those resins and fiber to customize our product, to develop our product. So we are looking for some industry who can participate into the development aspect of that. But yes, design of composite structure, even after procurement of fiber, both like fabrication, testing, even testing also, like getting zero CT. Zero CT means it is insensitive to temperature. So even we design a zero CT structure, testing of the zero CT expansion zero, that needs a instrumentation, high order instrumentation, that those developmental parts is there within the issue.
Question is to Mr. Lalit. As a leading player in composite manufacturing industry, how is Link Composite navigating the challenge of high production cost and limited domestic supply chain in India? First of all, Are we agree that we have limited supply?
Yes. I think we are agreed on that we have limited supply. So in domestic, we have a limited manufacture of the raw materials, and that's why we are importing a lot from other countries, China, Paris, everything.
So, any strategies are you implementing to remain competitive in the market? It's a personal, but because
Yes. So we are investing as a new plants. So we are expanding our facility, and we are going to collaborate the foreign companies. So right now this material availability in India is less. So we are going to do a partnership with other companies so we can bring the technology and then we can start the manufacturing in India. So that we are already in the process. We are signing JV with other companies. So soon we will disclose also.
now that was regarding some of the questions. Now we come to academics part somewhat. So as we have gone through some of the lectures and mostly in our academics, whether it's a chemical engineering branch or a mechanical engineering branch or it's a polymer field or textile, they are studying specific things. And this composite involves the multidisciplinary approach. So it's very challenging to develop the engineer who is having complete knowledge of the composites. So that is one of the most difficult challenge that we are seeing right now. And I think just now we have gone through that specialized course in masters at Ahmedabad University as well as IIT Gandhinagar. So I'll be asking the questions to Dr. Hemant Chouhan, who is from Ahmedabad University. Considering the current challenges, whatever we have discussed, faced by the lightweight composite industry in India, such as shortage of skilled labor and need for advanced research, how is academia is contributing to bridging these gaps?
Well, all the points were relevant and I had some of the other input to that. So maybe we'll start from here. As we all know, the research starts from top. So when there was no metal, first time ore came into existence and metals came. Few decades back, 5, 6 or 7 decades back, something like composite came into existence. And today we are like, that's the primary reason which Sir can enlighten us that okay, there are more than 6,000 satellites moving all around us. Just because of, I mean, one of the major reason happens to be composite. Had there been only metal, probably would have expected these numbers. The numbers would have been there, but much lesser. So we see that the science first develops from the top. So we have lot many PhDs across the globe. Yeah, might be the West world is far ahead of India. Yet in India also we have decent number of researchers or academic institutions, including IITs at the top, of course. So there is lot of research going on. But when, like he said, that in industry we look for, so industry is looking for the real labor who is going to work on the shop floor. Now there is a big gap. The one who has done research and PhD, we don't expect, nor the industry would like that a PhD has got a blue-collared job kind of and he's working with the resins. He should be more of a scientific nature. So this is the first of its kind initiative that we want to bring that knowledge from PhD to masters. Definitely it can't be equal to PhD, but at least he'll know all the aspects of composites. So that will bring a stage closer to what industry is looking for, so that they can serve industry in a better way. So that is the primary objective. We can fill that gap from that. And I'll take some examples like Sir mentioned. I would say that in last 2 to 3 decades, carbon fiber has become a standard. Aerospace means carbon. At one point we say it's good, but at the same time, as we said, that there is a need of innovation as well. So we all agree. But that part is missing. So if we have new task force, new members in the team, the new generation, then that part can be only taken up by the academics. Just we won't have time. time for that, and space organizations won't allow to experiment with in the space missions directly. So that is one part. So that is something, sir, which I would like to add, that we are somehow entire globe, not just us. It's to all the mankind that we are in that trap. Aerospace is equal to carbon.
Actually, we had I think one ma'am was there from IIT Gandhinagar. So we had certain issues like swing back of hardware once we remove out of board. We are looking for some researcher who can dedicate, who can explore the theoretical aspect and explore or generate a model so that we can counteract or compensate so that those swings can be compensated, or at least we can give a corrective measures in the mold so that after swing back we can get a desired shape.
Well,
so that is one example. That is one
the
example.
raw material part of it. We
Raw
are stuck
material,
with that,
yes,
okay,
actually,
there is a limited set of resin, there is a limited set of fiber we will follow. And we are not willing to experiment with something new. Yes, you don't have time for that. That will always begin with academics. So that is what my point. And adding to that dimension, sir, I came from the defense side, bulletproofing area. So recently, Reliance, one segment of Reliance actually, they have started working on the development of ultra high molecular weight fiber tape, not fiber form, not the filament form, but the tape form. So there is a bit of a technical difference between the two. Who has been doing that? So yes, the work has started, and UHMWP happens to be one of the most costly affairs because that comes from bulletproofing background, high strain rate applications.
I am also from academics, and I had guided 10 PhDs and more than 70 MTechs till date. What difficulties I had faced in the initial stage when I started my PhD in 2003, I was just looking for the banana fiber, and I asked from the Kerala. Parcel came, then postman came. It was smelling like anything. My wife told that what has come, what you have ordered, something. So it was something scam kind of thing, and so, but that was a learning experience because just now in the morning we were having wonderful lecture with Professor Inderdeep Singh sir, sustainability. As being from academics, we are more interested in that, looking to environment and other things also. Other thing I want to point out, as industry people are and R&D are here, as academics, sometimes all institutes are not having all the facilities available. So, even though they are interested, but they have to look around and take the help from the organizations.
I can add a dimension to that, sir. And that is like, as you know, and I probably missed to mention in that first.
That is missing actually. And,
so here, like
this kind of
is in collaboration. It's the university, the Ahmedabad University, but then a major portion is to be taken here by ATIRA. And ATIRA, we all know, is the primary member, supplier. So we have that good hand-holding of the industry, and that to the extreme elite class with ISRO. So ultimately the students are working on projects of ISRO, indirectly of course, not directly.
Actually, many of the time,
even first testing I had done at textile there only. That was the initiative. And but the viewpoint is that more collaborations and more interactions like this, that will help individuals.
Any of the time people are not knowing
that is the main thing.
Suppose in ISRO, many of the people may not be knowing what are the different facilities which can be used for development of composites. Same way, I may not be knowing what are the facilities in other composite development industry. So such kind of conference can expose those facilities to users so that they can use.
This is what we have been working. So manufacturing equipment, these are white elephants. All understand. Processing of composites.
That's what now actually ISRO now present development is. Government of India has given a free hand to ISRO that all the facilities of ISRO can be used by private vendor or startups who cannot invest to like very large vibration facility or very large thermohack chamber. So they can approach our ISRO facility and they can use with a minimum or nominal price.
Few questions I had asked, now generalized questions or some of the query maybe for the audience also, but few points of discussion like, do we have we are having absence of solid and concrete regulatory framework bodies for composites in India?
To some extent, I would say yes, because if you look at US or if you look at Europe, there are two bodies, which is the government body functions, science and technology sector, very actively in industry associations. They have a effort for standardization. Whether you look at it infrastructure area or any of the composite area, that is one of the reason why US composite industry is so developed. There is always one third effort by the partners. Something similar is there in Europe, maybe Germany, where industry and academic participation is either equal or higher on industry side and lower on university side. Make efforts towards more competitive, workable solution. Whereas in India, is still something to develop as only or as composite association or any of the knowledge partners of center of excellence. Center of excellence has to work in standardizing those aspects. I think in Atira we did when I was one of the forum member long back. We did try to bridge the gap with the Bureau of Indian Standards. So they already have some standards, but then how do you, those ASTM and all, you can bring it here and more useful in terms of what a product standard should be. So we did work on a couple of, unfortunately, one of the largest area at that point of application area was GRP 5, which was more for sewage and water. Government, I'm sitting here, that's why I'm mentioning that the government was pioneer in water transport pipelines, secondary pipelines. Did award a lot of tenders at that time, but somehow since there was no standard pipes, that industry has is completely vanished today as GRP piping. So we need to work on standards which are locally acceptable, and whether we work with BIS or whether we work with Center of Excellence and in formulating with the industry, that would help a lot.
Thank you for your dimension. Like you mentioned, sir. So I have to narrate rather a short journey of. We started a project. Army had a requirement that happens to be X. That was hard steel core AK-47 is the primary threat from Army. Here down the line, first time Indian standards for ballistic testing to existence. So now, what was the original question paper is now migrated to a new one because now we have Indian standards. When it started, it was to follow US standard, NIJs. And one and a half year down the line, now we have Indian standards. So few of the finer things of testing, now they are slightly deviated. Now who to blame him, how to, because the original plan was something else and now things has changed. The goalpost has changed. And by the end of what we could do, the army said that, okay, this particular threat is no more a threat to us. I mean, it's too small a threat. We have raised the bar of the threat. Now we are more concerned about sniper bullets than. So now again the question paper has been changed by someone else. The end is the end user. So ultimately the entire research is for that. Otherwise there is no point of research. The part that there was a US standard, then comes an Indian standard. And of course, as you rightly mentioned, majority of our Indian standards course, they are derived from maybe West or US, but then most of them have come into existence in last 1 decade. In fact, you must remember many of the committees or the BIS committee, we are in the stage of finalization of the Indian standard. They are yet to be finalized, including fibers.
That if industry people are giving some product, should they give the reliability of that product to the customer, that this much it is? That level we should think in composites. Because for metal, right now it is a
Yes, but you have a Bible there.
yes. Because
Here we
handbooks
don't have
are there and everything is there. But so if this is available, that can be achieved.
Also, as John was mentioning very correctly, there is also a requirement by the industry to have a international standard testing facility for composites. There are a facility available in IIT Bombay, IIT Chennai, IIT Kharagpur, but these are all underutilized facilities. I don't know really about now what is the status with Atira. They have a very testing facility, how effectively that is utilized. But if these testing labs are in a position to give certification for the industry, because I purely look at it from the industry side of view and from the commercial point of view only. And when I look at that part, 60% of our finished products, either in direct form or indirect form, its end user is government. Let's take it. So 60% plus is end user government. Whether you take transportation, infrastructure, or any of these areas. So composite per se in that is either you have a secondary contractor, primary contractor, or the level 4 or level 5, whatever you call it, the government tender process. So if the government is end user, then the government is looking at those standards. And if we are able to, combine these efforts from the knowledge partner in standardizing that, yes, there is a test lab which will certify product for you. We take the guarantee that if the product is manufactured as per this, will meet your end use requirement. So I have coined a word called fitness in use. So we need to look at fitness in use.
Actually, when you have the test, we go for like metal test, we used to real lab. Yes. But if I look for composite testing, if I ask some private vendor to like measure a coefficient of thermal expansion, not aware about what are the different standards to be followed.
You're very right.
For that. And that is
tailor-made fibers, structure, pattern, that is also affecting
the test, and because of lack of the standard of composites, maybe like commercialization of like you told about reliability numbers. When because of this standard, it will be difficult to get that reliability number also. Yes. Like whether to say 90% or 70% on what basis we know we don't have that goal.
The industry, they are asking products for composites, they are asking A bias or B bias. Error in terms that then 95% or 99.9% reliability. So it is very difficult right now to up that.
At the same time, there is another challenge. Handling the composite sample is extremely difficult when it comes to extreme composites. Had it been a glass fiber or gustal, it's fine. Things can be managed. But when it comes to extreme cases, like UHMWP or carbon fiber based systems, flipping, having a proper holding fixtures, without any error, conducting experiment with composite specimen in itself is that is one of the major reasons that standards cannot be like finalized. one party is agreeing to it, another one has said, no, we have experience of so we need to cater to that as well. That causes many of the times, like the standards, unnecessary or maybe stretched timelines.
More and last point of discussion regarding this lightweight process. Do we have low IP activities? Low IP activities, intellectual property.
Governed by resins.
Still, those people are working and developing, but that is not. They are not approaching this IP activities. So, is it so or
Actually,
intellectual property rights?
okay, yeah, I was under the impression of measurement.
Mainly in the government sector, everything is IP. Even especially for ISR, we don't disclose outside. So in order to get the IP, at least you need to disclose it. So to avoid that confidentiality part, many of the time, whatever development is done within the government sector, especially in the sector, those confidentiality can will but sometimes generic things used to be registered to get the IPs.
So like he mentioned for aerospace, I would mention for the defense. So in ballistics, bulletproofing, neither the raw material nor the end they are interested in filing the patent. So it's really difficult. At the same time, we are not even allowed or preferred to share the results. You became a success in a particular threat level, or you became a not success in a particular threat. So it is discouraged that you disclose the result, because ultimately you are going to share the result to the globe. So your neighbors and your counters are also knowing the result which government or the organization. We do agree to that. The defense data, so it should
In
not.
short, we can say that if it is research based and some critical applications are involved, right now in India, people are not going for that. And if it is a commercial product, if it is to be used by many people are going still for that.
Then it's a trade secret. Then it's a trade secret. So Reliance comes to us and they say they don't. We are not doing.
Strong. Look at the kind of I'm taking DRDO or DRDO. The patents are there, the technology is available. It was not commercialized for last 30 years. Now, some of them are being shared with the industry. That yes, this technology can go into the industry. Industry can do the manufacturing. Those areas. Then they have a confidentiality there. They have an where it is one-to-one only and that way. But one of the another area that I would like to at the challenges. If we divide this whole industry into two parts, where Chouhan and Mr. Patel is sitting one very high-tech area of defense and satellite communication, and on my right I have a young boy who is on more commercial side. We look at the biggest challenge that we see now in the composite industry, mainly the commercial composite industry, is recycling. And in the morning, yes, Cince did talk about thermoplastics, thermosetting, and what recycling can do. Work is already in place. Some of the things, the challenges are already addressed, both in terms of commercial carbon and glass composites, where recycling is happening, patented. And I think in next 5 to 10 years, we will see a lot of those matrix systems coming in with recyclable properties, where especially in aerospace, pre-preg side, And also on renewable energy side, we see a lot of these recycling systems.
Now it's open for the audience to have specific questions.
Yeah. So you were talking about the lack of availability of raw materials from Indian suppliers. I think Mr. Patel mentioned that when it comes to specialty applications for Indian suppliers, and those products are mostly imported. So the only way that you can develop local suppliers is if the manufacturers of composites are either encouraged or if you place some kind of regulation to increase the amount of raw materials that are locally manufactured.
We are not able to.
Actually, it's not audible here.
Not audible clearly.
Sorry.
Please come here.
Excuse me, you can speak from there. Or you can speak little louder there.
Yeah, sure, I can speak louder. Is that better? Can you hear me?
Slightly.
Okay. So you made a point that that the Indian raw materials, especially for specialty applications, you don't see a lot in the market and you're forced to import because of the lack of availability of those raw materials. So if you want to see more Indian raw materials being used by composite manufacturers, then you need to encourage them to use those Indian raw materials or help raw material manufacturers develop those products. So how would ISRO, for example, or the Composite Association not just regulate, but I guess encourage composite manufacturers to help raw material manufacturers develop those products? You know, something like your FAME subsidies in the automotive sector, they require a 70% local raw material usage. That has greatly encouraged people to start developing specialty raw materials. So how would you do that in the composite sector?
The question is whether, like, whatever special material is required, instead of importing from outside, what is the government's initiative to do it within the India? So if I share 2-3 examples, like nowadays for procurement, we look at government institutes. We have a requirement of like Make in India. Our policy is like that it has to be, if something is available within the India, you have to buy it from India only. You cannot go outside. So that policy will enforce or it will help Indian startups to, or it will promote the Indian startup to develop something new. Second is, earlier we had a policy that something if we want to procure from outside, we were mentioning that they should have a prior experience. They should have a prior 4-5 year experience in the similar field. Now to encourage the small scale industry or startups, those terms is removed from our procurement. We always love to encourage startups for developing something new. And third thing is, like, we have different channels like Respond. So we have a Respond model where if some industry as well as some academia, suppose for Ahmedabad University want to develop something on resin which is of importance to our application, or fibers which has an importance to our application. We have some funds which can be given to those institutes who can develop products which are required for ISR. So that fund also will help researchers to R&D or development which is required by ISR. So these are the few examples I know. Many of the things I may not be knowing. Maybe Government of India is now continuously behind encouraging the Indian industry to develop and to eliminate the foreign imports, by which we can save the foreign exchange. We can generate employment within the India. There are different models like Respond is there, some other models also will be available, which will encourage Indian startups, Indian entrepreneurs to develop products which are required for India.
Like as you mentioned, in both these fields, aerospace and defense, what happens? There is a weight restriction. There is an upper limit of weight. You can't go beyond that. That adds a dimension what he has correctly mentioned, what government initiatives are, there is an upper limit to weight and there is a requirement of mechanical properties. Unfortunately, till we meet those numbers, it's really difficult to use those components. I hope sir will agree to that. So that is another major challenging area that in many of the extreme testing conditions, many of the products unfortunately could not perform to the desired level. So, but the good part is that government is still promoting in the name of negative import fees. So I have been dealing with a couple of defense products again. So if army is getting something from the westward and there is a weight X, India is producing X plus delta, government may push it. When it failed in terms of mechanical performance, then there was a challenge. So that definitely adds a dimension. Having said that, okay, we qualify, that won't work many a times. I hope we can add.
So, what are the applications of composites in the area of railway?
Okay. Sir, I hope we should have the entire wagon out of it.
Now, current applications.
Current application.
Future application. Current, do we have any applications?
Many of the component interiors of
made from the composite, whether it's the window panel or this roof ceiling, floor panel, it's all from composites. Toilets also, water tanks. All this modern railway, all the toilets are made from composite. 100% composite.
That to low cost composites. So that's a good part. Like 1/3 in weight, nearly slightly above 1/3 kind of. And the costs are also pretty moderate.
Another question is that we talk about 3D printing for polymer composites, metal. Nowadays, there are printers available in the market for printing composites. Probably that also should be considered. Probably your business. That's good. Otherwise, printing using composites.
The good part, we have fiber now. Not so good part, we cannot have a continuous fiber. So when we say 3D printing intermittently, we may require to stop printing, depending on the complexity of the change. So what to do? So we cannot have printed a continuous fiber. Whereas when we say any of the application-based fiber, leave the training, we are happy with the isotropic kind of a material, homogeneous. So we use a random. But here, if we are having a nozzle operated thing, then we can only expect material from one direction. So continuous fiber and continuous or unique kind of a phenomena that has got a lot of benefits. So on that front, there is a difference. Otherwise, yes, in 3D printing now we are having a lot of chalk fibers.
Any other questions from the audience?
I would like to share one small desi example of my childhood. I am from small village. My mother, at that time there was no plastic bottle. उस वक्त क्या करते थे जो पानी वगैरह मतलब अनाज भरने के लिए कुछ पैकेट्स चाहिए तो हम लोगों का स्कूल खत्म होता था ना तो जो बुक्स होते थे उसके पन्ने फाड़ के उसको पानी में भिगो देते थे एंड देन गांव में इमली होती है इमली उसके जो सीड्स होते हैं ना उसको पानी में मतलब थोड़ा बॉईल करके उसका सीड का जो पाउडर होता है दैट एक्ट लाइक अ रेजिन इट एक्ट्स लाइक अ रेजिन एंड जो पेपर्स थे उनको पूरा मैश करके तो रेजिन ऐड करके देन शी यूज्ड टू टेक वन लाइक एग्जिस्टिंग बाउल और एक थाली जैसा रख के उसके ऊपर वो लेयर लगा देते थे एंड देन केप्ट फॉर सम टाइम एंड देन दैट पेपर एंड जो रेजिन था जो सीड्स का वो एकदम क्योर होके इट वाज एक्टिंग लाइक अ वन बाउल सो कंपोजिट अभी हम जैसे बात कर रहे हैं कि कुछ सालों से कंपोजिट हम यूज़ करते हैं बट इंडिया में कंपोजिट कई सालों से अपने जो पूर्वज थे वो कई सालों से यूज़ करते हैं आज काफ़ी सारे सुबह में मॉर्निंग में बायोडिग्रेडेबल कंपोजिट देखा तो मुझे वो रिकॉल दैट
So we'll conclude this panel discussion on the lightweight composite industry, present challenges in India. Very much thankful to Jitendra Mistry sir, Naimesh Patel sir, Lalit Khatri, Dr. Hemant Chouhan. And I think we have very fruitful and nice discussion on this topic. And in short, we'll conclude this discussion that the lightweight composite industry in India are facing significant challenges, that is including high production cost, a shortage of skilled labor, limited domestic supply chain. Despite the growing demand in sectors like automotive and aerospace, the industry struggles with the high cost of raw materials and specialized manufacturing equipments. Additionally, there is a lack of awareness and adoption of composite materials, hindering widespread use, regulatory hurdles, and the need for environmental sustainability further complicates this progress. To overcome these obstacles, the industry must focus on the innovation, skill development, fostering public-private partnership to build the robust ecosystem for the growth. Irrespective of these challenges, in last decade, we have seen much progress in this field, as we can see a lot of collaboration and a lot of research in this field. So with this, I conclude this panel discussion. Thank you very much.
Thank you all the panelist members and the moderator of this session. I would like to invite R.K. Singh sir. Sir, please. Sir, please. Chouhan sir. 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 Thank you, sir. Sir, Arun sir, please. Thank you.
एक ग्रुप फोटो ले लो।
Sure.
आगे जी।
आप आइए, अरे आप आइए। आप हमारे
So we came to an end of the first session of the post lunch. So we'll be